All right, hello everyone. Let's get started here. So your next assignment is due on Wednesday, and I got a question after class recently asking when is going to be the next quiz, and the quizzes are unscheduled, and so those can occur at any time. The pop quizzes are unannounced, partly because I'm not organized enough to know when we're going to have time in a particular lecture, and so I kind of just have to play that by ear, but then also it provides an incentive, an additional incentive for you to actually be here in class versus just trying to catch up on the recordings later. So quizzes can be in any time. One other announcement, please bring your laptop computer to class on Wednesday. If you don't have a laptop, then that's okay. You don't necessarily have to go out and buy one specifically for Wednesday's class. But there are going to be an increasing number of lectures where it would be very helpful if you have one. And so if you don't, you're going to just be kind of relegated to watching someone else solving the in-class exercise, and it won't be quite the same learning experience. There are laptops available for checkout from the library. If you don't own one, then they will let you check one out for 24 hours at a time from the library, and so that's another option as well. Before we get started on today's new topic, are there any questions about the announcements or the things that we covered in class last time? All right. Today we're going to get kind of deep into some theory. A lot of the decision making that we want to make going forward is related to picking the opportunities that are going to be the most profitable. And so today we won't actually compare alternatives. What you're going to do is start seeing the first seeds of ideas that later on down the line, those ideas can be used to find out whether option A or option B is going to be the most profitable for your company. And so that's a bit of background on why we are looking at a pile of rocks. This slide just is kind of an illustration of the method we're going to be using to determine the interest rate of a project, to determine its yield, in other words. And so this just illustrates balance, or we could make it a balancing elephant. In engineering economics, balance is when we have an equivalence of value. And remember that the only time an equivalence of value would have any meaning is if we're comparing amounts in the same time frame. And so this equation, the present value of inflows is equal to the present value of the outflows. That's what balance looks like in engineering economy. That's one version of it. We could make a similar statement about the present value of the future amounts and the present value of the outflows. The future value of the outflows, the future value of the inflows. But here, let's consider what if we moved all of the money in a cash flow diagram to year 0. And so this cash flow diagram is an illustration. What this summary is saying is that we made some investment at the present. So the downward arrow means that that's an outflow from our perspective. We invested $23,000, or whatever the currency may be. And then in each of 6 periods, we're receiving an inflow amount to us of $5,000. And so is this in balance? Well, maybe it is, maybe it isn't. It all depends on what interest rate we are discounting those future amounts to the present at. Who has a calculator and can tell me what? Oh, I guess we don't need a calculator for that. 30,000. I did it in my own mind. 6 years of $5,000 per year, that's 30,000. And so if the interest rate was 0, so in other words, if we're taking each one of these annual payments back to year 0 and we're discounting it at 0%, then they retain their full value. And so if there's no interest rate, then it would be $30,000 worth of inflow, and our outflow was only $23,000. So the net present value would be $7,000. Now, I really emphasized that, didn't I? Net present value. Let me emphasize it even further. I'm going to write that phrase on the board, which means you should write it in your notes. Net present value. Okay, so I used that phrase when I was saying, what if we moved all of these future revenues to year 0, and then we combined it with what was already at the present? And so net means the combination of inflow and outflow. So net is combination of inflow and outflow. Another way to think of net is what's left over to keep as profit after you cover your expenses. And so net, sometimes people talk about their paychecks, and they talk about gross and net. And that never made any sense to me until I started getting a paycheck, and I realized what you actually take home is very different from what you supposedly earned, because they take out money for your federal taxes, for your Social Security, Medicare, retirement, all sorts of little deductions, parking. So all those little deductions means that the amount you take home, your take-home pay, is the same thing as your net pay. And so that means the inflow minus the deductions. And so here what we're saying is that net is the combination of an inflow and outflow, and then present value. So we take anything that's not at the present already, we move it to the present, and we combine it with what's already at the present. So what's the net present value if we are discounting the future revenues at 0%? We're discounting everything at 0%, then the net present value would be $7,000. So we could say at I equals 0%, net present value equals 7,000. Does everybody see what I mean by that? Now, what if we have a non-zero interest rate? What if the interest rate, like what if we borrowed money to buy this equipment? And so, what if it's 5%? Is the net present value at I equals 5%, NPV is blank. So is it going to be more than 7,000? Let's just think in logical terms. We're not going to crunch the numbers yet. But in logical terms, if the money in the future is now being discounted at 5%, is the net present value going to be 7,000, more than 7,000, or less than 7,000? Less. Boy, that was a resounding, decisive, correct answer. That's the best kind. So one of the people who said it's going to be less, explain. Any volunteer? I'll just stand up here all day long. Go ahead.
When you discount money, you're moving it back in time.
Okay.
Interest is counted for the decrease in the value of money over
Okay.
time.
Okay, so then why is it less than 7,000? You're absolutely right so far. Tie it together. So he's saying when you discount at some interest rate, then the money, the amounts are getting smaller.
Today, less money for $5,000 6 years from now.
Okay, so like this, let's take year 6 as an example. The $5,000 in year 6, if we're moving it 6 years, and each one of those years, every time we move it back a year, it's 5% less, then the combination of all of those amounts is going to be less than 7,000, because 7,000 was how much it was worth if they didn't get smaller as we moved them back in time. But if each one of them is getting smaller, then it's going to be NPV is less than 7,000. Okay, so here's where it gets interesting. We could try lots of different interest rates. And what we're looking for is what is the magical interest rate that makes everything in equilibrium. So balance is when the inflows and the outflows are equal. So the best way to do things over and over again is with Excel. because it's a lot less tedious if the computer handles the calculations. So I'm going to show you a variety of approaches today. We're going to do it manually just to find the bounds of the right answer, and then we're going to hone in on the right answer in Excel. But the main idea is we're searching for an equilibrium where the inflows and the outflows are equal, and we want to know when do the present values of the inflows, which is all these revenues, what interest rate makes it so when we take them to the present, the amount is the same as the outflow that was already at the present. Maybe so far the explanation doesn't make sense, but I think the in-class exercise is going to help to clarify that. All right, so let me bring it up on the screen and I'm going to hand it out. So the first thing you do, today's in-class exercise, is you make a cash flow diagram. Maybe that should be the first thing you always do, a cash flow diagram. Your roommate asks you what you want for breakfast, make a cash flow diagram first. That should just be your reflex. You always do it, no matter what. Okay, so after the cash flow diagram, what I've provided is two factor tables, the 10% and the 12%. What you need to do is discount the cash flow diagram and find the net present value at 10% and then do the same thing at 12%. And that's going to be instructive about what we need to do. All right, so let me give you a few minutes and then I'm going to interrupt and demonstrate the solution on Excel. Let me show you the answer to A and B, and that'll tell you maybe if you're headed on the right track. So here's what the cash flow diagram should look like. We've got an outflow at the present in the amount of $60,000. We've got an annual series of 5 years at $16,000, and the interest rate is unknown. So we know A and we know P, and we want to take that A to the present. So that means find P given A, and part B is asking us to do it at 10%. So I equals 10%, N equals 5. So from the 10% table, you look up the factor, and that factor is a ratio. It's the ratio of the present value to the annual amount that keeps occurring. And so if we want to know what's the sum of the present values of that annual series, we simply multiply 16,000 by the factor. The factor, again, is a ratio, and so we solve for P, but that's just the present value of the annual series. We want to know the net value, meaning the inflows and the outflows combined. And so then we take the revenue minus the cost at the present, and so the net present value is going to be $652.80. Anybody else get that same amount? Good, $652.80. My hope was that the discounting of this annual series to the present would be second nature by now. If it wasn't second nature quite yet, my suggestion is to work through the last few in-class exercises this evening just to refresh your memory and give you some additional practice. Do you have a question?
Yeah, so if this was on a test, that wouldn't be 80 though, right? That would be 60,653 because we got that number from the table that has
Yeah.
things.
That's a very good point. Yeah. We have, we've got 5 here, 1, 2, 3, 4, 5 digits in that. And so we should round this off to 5 as well. And now this is where the 5 comes into play. So 1, 2, 3, 4, 5. So yes, 60,653. So it's only accurate to the nearest dollar. Are there other questions? So follow the same approach now for 12%. You have an A. You want to find out what is its equivalent present value if you're discounting everything at 12%. It's going to be less. It's going to be less because you're discounting it by a larger amount each year. Okay, so if we're discounting all of the future revenue at 10%, then the net present value is 653. If we're discounting at 12%, then that means those future revenue amounts are worth less than they were previously. So the value of the project actually is negative. And so there's an interpretation to this. What it means is if you had to go to the bank and borrow the money at 10% interest, the project could still be profitable. You'd be able to cover your loan and still have some leftover money. $653 would be the present value of that project. But if your credit's not so good, or if the bank is a little bit skeptical about your revenue projections and they're worried there's some risk, so let's say for whatever reason, now you have to pay 12% on the financing, then that means that the project value is actually negative. That means that the revenue you're receiving wouldn't be enough to cover the investment. So there's a crossover point, and that's what we're going to try and solve with Excel, is we're going to try and find out what interest rate specifically makes it so that the present worth is in equilibrium, meaning that the revenue and the costs are equal. The inflow and the outflow is equal. Before we start playing around with Excel, are there any questions about the hand calculations you've done so far? It's absolutely essential that when you see a cash flow diagram like this, that it becomes immediate that you know, well, if it's asking for present value, that means it's P/A. If that's not yet second nature, then the only solution is practice. All right, so here's the Excel part. What we're going to do is try and find out what interest rate makes it so that the revenue and the costs are equal. So I'm going to have, as we do these calculations, some interest rate that I'm guessing. So let's start with 10% because we already know what the answer is supposed to be. And we're going to have year, amount, and present value of amount. Okay, and it's years 0 through 5. Let me zoom in so that's nice and large. Okay, so in the amount column, we're just going to put the cash flow diagram as we see it. So it's negative 60,000 and 16,000. And I can repeat that just by dragging down here. You see that kind of thick green box? If I drag that down, it will repeat the value. Now, it's not absolutely necessary yet, but let's assign this the currency formatting, just because later on it's going to be more important. So I'm going to highlight these locations where I'm putting in the amounts that's money, and instead of general, I'm going to have it say currency. And that way we can see the dollar sign. I don't want to show those pennies though, because I'm not so worried about the small change on this example. So I'm going to decrease the amount of digits that's shown just because it makes the spreadsheet a little bit less busy that way. Okay, so these are the amounts. Now this column represents the present value of the amount. So what I'm going to do is I'm going to find out how much is this amount worth in year 0. And so I'm going to use the function equals PV because that will solve for the present value. Now first it's giving me some hints on what it needs to see in this function. So it's first saying what interest rate are you discounting things to the present at. So I'm going to go up here and I'm going to reference this location where I'm putting in the interest rate. And I'm going to press the F4 button to put in the dollar signs. Does anybody remember from 111 what those dollar signs mean? Absolute reference. It's sometimes called anchoring or locking. What it means is that if I copy that formula, it's always going to look in the same place so that it doesn't switch instead to like a relative referencing. So later on, I'm going to drag that formula down to the other rows. But by having the dollar signs here, it knows always to look in this cell for the interest rate, regardless of where this formula is being used. So I can either type those dollar signs in manually or what I did was I just pressed the F4 button. So I click here, and I press the F4 button, and so now I'm always going to be looking here for the interest rate. Okay, so now a comma. Now it's asking NPER. That is an abbreviation for the number of periods. So it's asking how many periods do you want to move the money in question in order to get it to the present. And so I'm just going to click on this cell that has the year that we're in. So it's going to move the 60,000 0 years. When I copy this formula down a row, it's going to discount this 16,000 by 1 year. When the formula gets used in the next row, it's going to discount this 16,000 by 2 years, and so on and so forth. Okay? I'm going to put in another comma. Here it's asking for a payment amount. Now this is really careful. You've got to be careful here. This is a place where people are continually making mistakes, because this 60,000 and the next 16,000, these aren't recurring payments that are happening n years. Actually, we're treating each one of them like it's a single future value. And then we're going to add it all up later on. So what we need to do is skip over this field. So we put in just another comma. So you're going to use this double comma thing a lot when what you're trying to find is the present value of just the amount of what row you're in. So I skipped over that, and then in the future value field, because each one of these is going to be a future value that's being discounted by n years, that's where I'm now going to click on the amount. And so I clicked on B4 because there's that certain amount there. So let me close this, and there's one more thing that we have to do to this function to get it to work the way we intend, but I want to show you why we have to do it before I do it. So when I type in enter, you notice it changed the sign. It took it from negative 60,000 to positive 60,000. And the reason for that is Excel always assumes that if you're telling it some future value, it assumes that you want to find out, if you're taking it to the present, how much would you have to deposit to have that in the future. So it always, in these built-in functions, is going to flip the sign. And so if what you really want is to know the magnitude of that amount but not flip the sign, then you have to manually put in a negative sign in the function. It's kind of annoying that we have to correct Excel like that, but it's its default kind of accepted assumption, and when we want it to do otherwise, then the correction is here in the function I'm going to put a negative value in front of the reference to the future amount. So now with that minus sign, 60,000. Okay, so if I drag this down, it's applying that same formula to all of the other cells. And let's just see if it did what we wanted it to. So the present value of 16,000, where each year it's being discounted by 10%, once it gets to the present, that $16,000 in year 5 is only worth $9,935 in the present. So first thing we want to do is just check the reasonableness. Does that match what we'd expect? And it does, because we know that money in the future is less valuable than money in the present. So if we take these future dollars, these 16,000 future dollars, and we move it to the present, it's going to be less than 16,000. So far, this is okay from a reasonableness perspective. The last thing that we do is we take the sum of the series. So this sum is going to give us the net present value. So I'm doing sum of all of these amounts, and we already know what the answer should be. Let's see if it matches. 653. Okay, it does. That's what we had calculated using the factor table. Now, they say drinking from the fire hose, you know. That's maybe drinking from the fire hose. You're going to get practice doing this in class on Wednesday, and that's why it's important to bring your your computer is you need to get as much practice using these Excel functions as possible, because using Excel is a lot faster than doing it manually. Is there anything I need to do over again, or does anybody want to see a certain aspect of what I've illustrated so far a second time? Everything makes sense okay? All right, let me just put in some borders just to be a little bit picky about it. All right, so that was if it's 10%. What do we know the amount should be if it's 12%? Less. Okay, that's when it went negative, right? So 0.12. Now, all I have to do is change that interest rate. Everything else is going to adjust automatically. Negative 23.24. Is that what we got? Negative 23.23. Yeah. So what Excel is doing is calculating the exact amount. That's correct to the penny. So that's the Excel method is using the equations rather than the factor tables. Okay, so now the question is, what interest rate makes this 0? So I'm going to say solve for the I value. It won't let me. Hey, I tricked it. Value that gives the NPV equal to 0. So that's what we're going to do, our objective here. So this needs to come lower. So 11. We're getting closer. 10. I went too far. What about 10.5? We're getting really close now. Let me show a few more digits of precision on this one. Does anybody know what method would be less tedious than randomly pecking about with values until I finally get it? Goal seek. Very good. So goal seek, if you don't remember, here on the Data tab, I do Data, and then What If Analysis, Goal Seek. Now my goal is I want this sum to be 0. And I give Excel permission to change only one thing to make that happen. It's allowed to play around with the interest rate. So I'm going to tell it, keep changing the interest rate until the sum is equal to 0. So that's the parameters of the goal seek. So set the sum to value of 0 by changing the interest rate. Okay? And when I click OK, it's going to keep looking at a lot of different values here. And it finally finds the value that's accurate to the nearest penny. So 10.425%. So what I'd say is the interest rate that makes the sum of the inflows equal to the sum of the outflows at the present is I equals 10.425%. So that's the break-even point between whether we should do the project or not do the project. So if you go to the bank and they say, we'll give you a loan at 10.1%, then the project would be a yes, because our cost of capital is less than the rate of return of the project. So the project would be acceptable if it costs us 10.1% to borrow money. But if we go to the bank and they tell us it's going to be 10.6% to borrow the money, then the project is not acceptable. Because then when we discount all those future revenues, the outflows are greater than the inflows. So that's a screening criteria for whether or not a project is acceptable, is you compare the cost of capital to the rate of return of the project. Any questions so far? Okay, the backside of the paper that I've given you asks you to consider break-even. So this is kind of abstract so far, but I hope the way that I've asked the questions may guide you towards a discovery. So see if you can make heads or tails of what I'm asking here on problem number 2. Okay, so in the problem statement, A, the recurring amount is 8,000. P is 60,000. So A divided by P is what? So if we do A divided by P, then that should be 0.1333. All right. Part B says, use the table below to determine the number of years until the investment is profitable. Well, this table doesn't say anything about profit. So you kind of have to make an intellectual leap there. I'm trying to teach you through the question itself. And the lesson is, if you think about it logically, if you only have 1 year of revenue, are you profitable yet? No, because you've only got 1 year of $8,000 and you paid $60,000. So you haven't quite broken even yet. You haven't paid off the equipment if you only had 1 year of income. Well, what about 2 years of income? Probably not. Now remember that each of those future income amounts we have to discount to the present. And so that's what this A/P table tells you, is it says what's the value of the present, the ratio of the annual to the present amount. And so when you calculated 8,000 divided by 60,000 and got 0.1333, that tells you how many, it tells you the number of payments that are required until it's broken even. And so if we look in this table, you'll notice that here between the 14th and the 15th year is where it happens. And so 14 years of that revenue is going to not be enough. You're not quite broken even yet. But once you receive the 15th year, then you have broken even. So we can't solve for some decimal value because the payments are discrete. So it wouldn't be like 14.8 years. It would be 15 years of revenue, and then you've paid off the equipment and broken even. So let me illustrate how we would do that in Excel. In Excel, we're going to have a new table where we've got an interest rate. So I equals, I'm going to put in 10%. That's the amount from the statement. We're going to have year, some amount, PV of amount, and then there's going to be this last column that's the cumulative present value of amount. I'll explain what that is in just a minute. Let's do all the rest though. So we're going to go 0 through, let's take a look at through 18 years so far. Now the amount is that we spent 60,000 and then we start getting these revenues of 8,000 each year. And the 8,000 continues indefinitely. We're just looking for the break-even point. I'm going to highlight and convert all of these to currency. Get away with, put the pennies away. All right, present value of amount. You've already seen this function today. Equals PV using this interest rate. Anchor with F4. N is the year that we're on. I'm going to skip over the payment field because each one of these is being treated like it's a single future value. So it's the minus of the amount. And so then we're going to get something that looks a lot like the previous Excel demonstration where each one of these future revenues gets increasingly small because to take it to the present, there's so many extra years that it's being discounted. So what this means is, for instance, this $8,000 in year 18, if you discount it to the present at 10% per year, it only has a present value of $1,439. Okay, now here's the cumulative. What we're saying is the first year of the cumulative is just the amount that went out that year. So it kind of means so far you're $60,000 in the hole when all you've done is spent the $60,000 to acquire the equipment. But in the next year, your cumulative present value is the previous year's amount plus the revenue from this year. So it's the cell above and then the cell that's just immediately to the left, that's adjacent. And so it's like saying, if you spent $60,000 last year and now you have this revenue that discounted to the present is 7,273. This is how much hasn't been paid off yet. That's what this cumulative present value means, is it means how much have you still not yet recovered of your original investment. So if I continue that pattern of the one above plus the one to the side, the one above plus the one to the side, and rather than keep typing that over and over again, I can just drag it down and the pattern will continue. What we see is that same crossover effect. Somewhere between the 14th and the 15th year is where, in the 15th year, now we finally received enough revenue that at 10% the project is profitable. So what we would say is, the scenario that's posed in this example, this equipment that you're buying, it better last for at least 15 years. If it doesn't last for 15 years, you're not going to be able to break even. So that's another kind of decision analysis you could do, is compare the number of years of revenue and the initial cost of the equipment with how long its service life is expected to be. Any questions about that? Okay. So for Wednesday, you've got homework number 4 is due on Wednesday. And please bring your laptop with you. I'll really emphasize the need to practice these in-class exercises. If you want to do a B or an A in this class, the bare minimum isn't going to be enough. You're going to have to find other ways to practice and supplement your study. Okay, I'll see you on Wednesday.